Hello, everybody, on our final time slot for today. And today, I'm very happy to meet here Sebastian Daschner. Sebastian is a Java champion. He is the author of Architecting Modern Java EE Applications book. He's participating in many open source standardization processes, in many open source software projects, author of blogs and videos, and first and foremost, he is a big friend of Jugru Group, and we're always happy to see Sebastian here. So we're very glad. Hi, Sebastian. Welcome to Heisenbug.
Hello, and thank you very much, Ivan, for that nice introduction. And yes, I'm very happy to be here, and happy to talk about some test stuff, which I think is an interesting topic for a testing conference.
Yeah. And very important one. Yeah, and by the way, maybe somebody just don't know Sebastian and the way he delivers his talks. So Sebastian never uses slides, uses Vim instead, plain text instead, and we'll see a lot of live coding here. So we're anticipating this.
Yes, that's the plan. So let's hope that everything works out.
Yeah. Do I get this correctly that in a nutshell, your talk is going to be how to make your Java tests simpler. Just use the necessary stuff.
Yes, simpler, but also I would say faster, more effective, and I would also say more fun. So this is really what I'm also seeing in projects, that you can really improve the test whole situation by actually thinking about, which technologies you need, what you can simplify, what you can make faster. And we're going to have a look at a few of these things today.
Okay, cool. I think it will be a lot of fun. Just want to remind our listeners that you have a chat, and please don't hesitate to ask any questions at any time. It will be very important. I will interrupt Sebastian and ask your questions. So afterwards, of course, we'll have a Zoom chat, but don't hesitate to ask your questions here in the chat. So I think we can move on to presentation, right?
Yes, so let's start. So well, thank you for watching and for attending. So I'm very happy to introduce you to the talk, why Java test frameworks are overrated. So, well, a little bit of a daring title, but I think they are, at least for the most part, at least for the JVM test frameworks that interfere too much with your test lifecycle. And I will show you a few things there. So for myself, well, I already was very nicely introduced. So that's my name, and I do a lot of stuff, usually in the Java space. But also, since this is a testing conference, I think while testing is a topic that is very much underrated, a very important topic, and also a topic that can be really fun. I really believe that, at least if done right. And I will show you why you don't need many fancy test frameworks, but why keeping your technology simpler can often be a good thing. And don't worry, as Ivan said, I don't have many slides. So actually, well, I want to do live coding most of the time. I just want to briefly show you which application I'm going to use because, well, I'm a big coffee fan. So lubię coffee. So I will show you a coffee shop application. But also for testing, I think it's really important to show not just hello world, but like some helpful example. Because when you go to many blog posts or read some articles, they show you, oh, just use this test framework. It's really easy for this hello world scenario. But then it's like, but the real world is not about hello world. It is more complicated. So I want to show you a scenario that is more complicated. So we will have one application that is called Coffee Shop. So for which we can order some coffee, for example, using an HTTP API with a user. And it already has a database, so some persistence, as you see here in the editor. Okay, and just to make it more interesting, we also have a backend, this barista person who brews your coffee. And to have it more interesting, that's going to be an asynchronous call. So we, have to test this in a somewhat way that, well, everything works. So this is basically the scenario. Now, before we go into testing, I want to show you how this works just in production, in a local setup. And what I have for this reason is I have my project here. So all of this code you can get on GitHub. It's available, which is the coffee shop application. So this project, which is a Quercus project. So Quercus, in case you don't know, I think is a very cool enterprise Java framework. So I use Quercus to do this. And well, it comes with many enterprise features. So this is a really, well, a nice runtime. And my coffee shop is a Quercus project here. So basically what we have, well, a lot of code that we're gonna a little bit go into, but for now I just want to run it and try it out. So for this, I have some scripts to build and run it, which just mainly does, well, a Maven build. So quickly build the project. And then I also run it locally. And I run it using Docker containers. Why Docker containers? Well, because it's a very easy way to run this locally, to run a test setup locally. And we're also going to look into that a little bit later. So if you want to work efficiently, I think you just have to be able to, well, test and see everything in a local setup. So I have 3 containers. Why 3? Well, one for the coffee shop, which you can see here in the slides, one for the barista backend, and one for the database. So the database is a Postgres database, which you can see here in a Docker container. One is the barista backend, and one is a coffee shop that I just built. So the script just builds my project and runs it. And now if the whole thing is running under this port, I can just access it. So I get some API hypermedia response here where I can, well, order some coffee, where I say, well, please, post something there. And the user can use an API, an HTTP API. So for example, I can use curl to say, well, give me the coffee orders, for example. And the coffee orders, that's an empty array, they are empty. And then I can order some coffee. So that's very simple. For this API, I can say, well, post some JSON here. And then post, for example, I need to have a structure. I will explain this a little bit later. But I need a certain structure. For example, I want to order some certain type of coffee, like an espresso, and then also a coffee origin. So the origin is as follows. In the better coffee shops, and well, in cities like in St. Petersburg or in Moscow, you have really good coffee shops, I know. In the better coffee shops, you can choose some coffee beans. For example, you can say where they're from. Like you can say they are from Colombia or from Ethiopia or Brazil, or, like some nice coffee, depending on your taste. And if you can choose them, then you can order here a specific type of coffee from a specific origin. And now, if this is the case, then my API says, okay, 201 created. And then I have the location of this coffee order, and I see the order is in the system. Let's format this. So here, it's Colombia. And now the interesting thing is the status, because this is going to be updated by the barista system. So here I take the user to persist some coffee here, and then asynchronously it's going to be sent to the barista, and this updates the status. So now I was too slow. I will show it to you again. If I order some new coffee, at first the status is preparing here. So it brews your coffee, and then the status is finished. And if the customer comes and collects the coffee, it is collected, which internally is a timer, for demo purposes, but it has some asynchronous status update, which is going to be important for our test. So we would like to test this as well. Okay, so this is a very basic, but complex enough use case that involves some asynchronous processing and some database, some persistence that we would like to now verify. And now what I'm going to do at first, well, we have very different types of tests. And, if you think of this testing pyramid, now today I want to start like from the top of the testing pyramid, or from what is called system tests. And in a system test, well, there are many different ways. Some call it integration tests, some call it acceptance tests. I mean, for me, a system test is running a system in a similar way, like you would run it in production, but it can be locally, like on your computer, but then also testing the system in the same way. So like having no differences. And this is really an important part, because otherwise, if you run your application here in a different way, like you would run in production, then you have some differences that might, well, just have a bug or that might change in production. And for that, what I will show you is a system test that acts like a user. So it will use the same API that I also used, like curl on the command line, and it will access the application here just in a way that then will tests it. And also the application will communicate with the barista system, but in our case, we use a mock. We will use a wire mock technology for this, which is very similar to what you would do on a code level with Mockito. For the database, it depends. You can have an in-memory database or a different setup, but especially with Docker containers, it's very easy to use the same technology. So I use the same Postgres database for this way as well. Okay, and now in this setup, what I want to do, I want to have a similar test that I had here. So I want to create an order like here, and then I want to see that the order is in the system with the correct information. So I can access this order and say, is it an espresso from Colombia? Yes, correct. And then I also see if the state is updated. So that's the second test, if the connection is correct with the barista so that it works correctly. And this is quite interesting. Now the question is, well, how to solve this? And you know that there are a lot of, well, test frameworks that say that make your life easier, especially with Quercus. There is a Quercus test. If you use Spring, there is a Spring test. What do? They aim to run your application in a little bit like mode that is similar to production mode, but I think it is not, well, the most effective way. Why? Because in a real world project, when you have many, many tests, this can become very cumbersome and can become very slow, depending on how you use them. And for me, the easiest way is to say, I want to use it in a very simple way that is very similar to production. So ideally, I want to use it in a way that also uses just local Docker containers, for example, like this, and then I can control them myself, and it is more flexible. But let's see. What I will have, I have a separate project for this that is called a system test project. So this project only includes test code. And why I have the separate project? Well, not to deal too much with the production code. So I don't want to use the production code here. Actually, it should be separated just to be sure that the test works as expected. Because if I change both the production code and the test code, then it might have, just a match and the test is green, although I changed something and I want the test to break. And what I want to have is a naive test first. So I will tell you in a second why it's called naive test, maybe because it's not that perfect, but basically a very simple approach using JUnit. So JUnit tests that uses this system test here. What does it do? It has an HTTP client. If you come from the Spring world, this is very similar to a Spring REST template that you can use to access my application here, like localhost and this port. And then what I do, I create the order. And now I will show you this code, and probably you feel reminded of your own test code or test code of your projects. And I also want to show you, well, why this is not the most perfect way to do this. So what I do on a Java level, I do now the same what I did on my command line. So I say, create a new order, Espresso Colombia, create a JSON from this request, then send this JSON via HTTP post, and then check if it's successful, and then get the location that gives you this URI of the order, and then load the order again, and then make sure that the order is the same, contains the correct data. So this tests that your database works correctly, that it was persisted. And then also check if the list of all orders, like this orders resource, contains this order. So there's that. Okay, well, so you see this code. And now think for yourself, do you think that's perfect? No, because it's too complicated. Why? Well, it has too many concerns. It has the concern of what happens in JSON, what happens in HTTP. It has the concern of the actual test, like the business test. And this is just too confusing. And especially what happens if something changes, or what happens if you have a new functionality. For example, if you say you would like to have not only espresso, but Colombia tomorrow, right? Well, then of course, what happens. You're gonna copy and paste this, and then, include a second method and say, well, for example, have a second method for cappuccino, and then look through the code if you need to change something else. But you see, this doesn't make sense. It's too complicated. So for this, well, it's not a good idea. I will delete this again. But instead, what you should do, and now don't tell me, well, you need some test framework. No, I think what you need is a test code quality, because now this test, what it still does, it only runs on a test code with HTTP. So you don't need to include any test framework. I can simply run this test. And for the test, I will just start up my test environment, which I will show you in a second. I have a slightly different setup for the test environment, because what I can do, I can have these life cycles independently. I can start up my test environment locally and then keep it running the whole time, which you will see in a second. It's much faster. It's more effective. So what I can do here is that I can say, well, please just run this test here in my IDE, for example, and then it runs really, really quickly. You see in a few milliseconds. And I can run it again, and I can run it again. And every time it will create a new coffee order, which you can see here. So I have one more order, and one more, and one more. Now I have two more orders here. So you see this test round trip time is very, very short, which is important for me, because while I'm coding, I don't want to, wait, because when you wait, you get distracted. When you wait, you check your phone, you read the email, you read the news, which is a bad idea. So, just trying to keep in the flow experience and say, well, I don't want my test environment to make me wait. And then typically, if you think, how long does your Maven build take, And so think of this for a second in your head, like your Maven build, or if you use Gradle, how long does your Gradle build take? And if it includes all tests, if it takes longer than just a few seconds, this is too slow. And with a lot of these tests, what happens is that if I use a test scenario with a technology such as Spring Test or Quercus test that tries to build up everything here, it will take way longer, because then it needs to instantiate this. So, if I would like to use test containers, or if I would like to use another approach, I know, these technologies are very good and very advanced. And, I know the creators of many of these, and, we're in contact and everything. But on average, I think it just makes more sense to start with something simple, and then, create an environment that is very effective for you. So here, for example, I showed you that you can run this test really, really quickly. It works really quickly on in the IDE, or you could run it on a command line. It's probably even faster. So this works really well. But what I want to show you now as a second thing is for the test code quality, that you actually should, care about the test code quality and use abstraction layers and delegation. Compare this test now. This is the same test: create order test, create verify order. New order, espresso Colombia, coffee order system, create order, URI. Okay. Then coffee order system, get order, assert that matches the order data. So some custom assert here, which you can create, which is very cool. Just a helpful small library. I wouldn't call this framework. I use typically, I didn't show you, 1 second. I use typically JUnit, Mockito, and assertj on this in this path. And this is really helpful, because here you see, you understand it, it's readable. So you see this test code and you immediately see, okay, you know what happens. You create a new order, you load the order, you check the data, and you see if all the orders contain this URI, and finished. So that's really easy, and you can then, understand it. Now, if you want to understand what happens, how to create the order, this is not part of this method. So that's a different abstraction layer that's delegated into this system. And if you think about it, if you use a different test technology, for example, with injection, like Spring does, or like Quercus test does, then very often it doesn't allow you to have your own, components. Sometimes you can, but it becomes more and more complicated, and it takes longer to build up because this dependency injection needs to be set up as well. And here it's very easy because it's just Java code. You say new coffee order system, instantiate this, and say get orders, and you have the lower level logic here encapsulated. So the nice story about this is if I write even 50 test codes here using this structure, it's very readable and it's maintainable because I see what's going on. And I think this is more important. So if I now start this test, you see that's also super fast, and I can change something in my system, and I can, test again and test again. Or here, that's going to be the second test that is more interesting, that uses a separate system as a mock. So here you remember maybe this one, the system test can also control the mock, the barista mock, and verify if this communication was done correctly. So this is important as well, that I know that this actually works, like this finished, collected, and so on and so forth, which we do in the barista system. So now check the second method here. The second method takes a little bit longer, but this is not because of my test technology, but this is because the business use case takes a few seconds, because this timer runs every 2 or 3 seconds or so. And now that's why it takes 6 seconds. But the test itself is very fast. What does the second test do? I say create a new order, and then it says, well, answer and wait for this order. So wait for the invocation. What does it do? Let's have a look. The barista system connects to WireMock, which just says, okay, I know that this barista, the local host, the second one, is a WireMock server, so I can connect to it. And then I can tell the WireMock, well, please return a specific status for a specific response. So I say stop post for processes, this is the URL, and then please return the specific request body here with order and then the status and so on and so forth. So this works really well. But what I need to do, I also need to have some wait. So this is, well, I do a while loop here with a wait because, well, I just need to wait. I don't know when the request arrives. So what I do, I just have to wait for this invocation to happen, because it means I set up my system to answer, to do the stubbing. And then I order the coffee and say, okay, now please wait until you are invoked with this preparing status. So that's important that I know that this invocation did happened. So it says wait for invocation. And this is just, well, there's not much better way. This is just pragmatic, that you wait for a specific time and then see if it actually happened. And then if it happened, then get the order again, and then check that the status updated to finished, and then afterwards to preparing, and then afterwards for finished, and so on and so forth. And then you can check this status update. But you see, this is a more complicated or more complex test, but still, if you use a proper code quality structure, it is still readable. So you can still say, well, I understand what is going on, I can comprehend, and I can read it here. So I can run this again. Again, this way takes a little bit longer because it needs to wait for the status update, which takes 2 seconds or so each. And then it will just do this twice, and then it will return. So in general, this test mechanism is very, very quickly. And well, that's now an important part. How fast can I get feedback while I'm coding? And this is really important, because when I'm coding something, I don't want to wait. I said this before. And I think the test waiting time is one of the biggest problem when doing testing, because you need to wait for a long time. And for unit tests, we will get to unit tests as well, but for unit tests, it's easy. But for system tests, it's usually a problem because you need to set up the test scenario. So what I do, I set up my test scenario up front. I don't use any technology that couples the test lifecycle from the test environment lifecycle. Why? Because then I have more control. I can reuse my tests quite quickly, and also it runs faster overall because I don't have to wait for the reload or for the start. So even if there's some optimization, it always takes longer to use a test technology that tries to build up the application. For example, I can go here and reconfigure with a system property where this test goes to. So if I deploy something like on a Kubernetes test environment, I can use the same test and just run it with a different test property and say, set localhost to my test URL using this port or so, and then it will just connect to the proper URL, and then I can reuse the same test. It will just use the same scenario. This also works. You can check out the code. You can test the Kubernetes example here. It's also very, very fast. So with this, what I want to show you is that this is actually a setup that allows for some changes in my application. Why? Because it uses this Quercus. So this is really cool. Quercus has a big developer experience features. With you probably know this Quercus development mode, which works as follows: that I can change some code and see the changes being reflected very quickly. So I can, for example, say I want to change something in this index entity mapping here. So I can say hello world. And then I invoke this again. And if I have some changes, you see now the change is immediately being reflected. This was very, very quickly. And now the interesting thing is, this also works in remote dev. So the name is called remote dev. And I set this up here in my environment like this. So this is now a little bit more complex, but really cool if you set up such an environment. Why? Because you can change everything in the test code, in the production code. And because of this development mode, you can really quickly update it. And you can really quickly rerun the test. So this is really nice. If you say, I would like to have a look at that and see the changes being reflected. So I just change my production code, I rerun the test. So I can go and say, rerun this test. And you see it's very quickly, now it's green. Then I can say, okay, I changed something else. And I rerun the test again and things like that. So for me, it's just very important that you keep in this development flow experience, that you don't have to wait longer than 2 or 3 seconds. And then, you don't get bored. You're always, in a very productive mode. And I think
Sebastian, a quick question. Does this mean that your tests, what you are calling system tests, also terminology might be different. Somebody might call it end-to-end test. Does this mean that these tests might be sort of idempotent, so that you can run them again and again, and they will not spoil the data? And in general, what do you do to prepare data into your database before this end-to-end or system test?
Good
or maybe
question.
Clean it up after each test.
Yes. In my case, I call them system tests because for me, I set up this barista in a mock. So I don't use the proper barista, right? Like end-to-end test for me would be more like I use this in a staging system, and then I end up with actual coffee, right? Because I use the real barista and something like this. But here in the system test, I use a different one. So this is mocked. So just the application runs in the correct way, and the rest is just mocked in a similar way like you would mock a unit test. And the database is also controlled by your system test environment, by your local script to set it up, or if you use Docker Compose or Kubernetes or something locally. And then you can use the database with some loading script so that you have the data being populated. So I would just use this in that way. To answer your question, my script looks a little bit complicated in the beginning, but actually it's very simple to say I use Docker. And for me, the easiest way, I know there are many ways to run Docker, but I'm just very pragmatic on this. I say Docker run, and Docker run here. So this is just the easiest way to build this up. And when I say I want to have some extra data in my database, I can just deploy it here, and then it's populated. And after the test, I can either wipe it or have some script that drops the database. So this is for me just the easiest way to use this in a simple scripting approach. So I would say that. Did this answer your question?
But in your teardown, I cannot see any teardown methods like after each. So you don't clean up a database after each test.
Yes.
And
Good question. This depends how your state of the application looks like. In general, I would advise not to clean up. Why? Because in a real production system, also the user typically doesn't clean up, right? The user sends an order and then the order is in the system. So of course, then you can say like delete the order. But in many cases, I just want to add to it and see if it still works. But this depends on your use case. If you need to clean it up afterwards, then I would have like a after or after each method here that just cleans it up again. Yes, you can do this as well. So it just depends. Okay. I wouldn't do, but yeah.
Okay, cool. I think we can move on. Lots of other questions, but yeah, let's move on. Okay.
Okay, perfect. Yes, so I basically use this to build up my application, but I already showed you. I will show you some more examples how to do this. So you will get some pointers how to set up a remote dev mode for Quercus, which I think is really cool because now this whole thing, these 3 Docker containers, they run in their Docker network. So the networking approach works, that is similar to production, but still you have the possibility to control the barista and also to run everything here in development mode. So if I say I want to change some code, then this change is, IDE was slow. This change is being reflected really quickly. And if I want to rerun some test, this is also just done very quickly because I just can start the test and I don't need to wait for a lifecycle change. So this is the important thing, because every time if I would need to update my environment, maybe with a test containers approach or a Spring approach, this would just be slower than having a separate lifecycle for my tests to my test environment. So I think this is just important to build up this more efficiency. And unfortunately, most testing frameworks don't really support this because out of the box, they want to be helpful. They want to build up your whole application and everything, which you think is nice, but it's not really helpful for a bigger project because then it's it doesn't really help much. So for example, I have one example here, but I disabled it because it was just a few seconds, I think not fast enough. To say Quercus test, this is very similar to Spring context test that just build up your Quercus application. And then you can say, well, test something, for example, go to the health check and see if everything works. So like this and things like that. But it is just, I think not the most effective way. But as you saw, when I have a way where I can quickly change something in my code, reload the changes, rerun the test, this works well. Okay, but I have one more thing that I want to show, which I think is even cooler, because there is also a way to run your test project with Quercus. So even if your test project, my system test project is just a Java project, even if this just runs with a plain Java way, you can add Quercus even if it's not a Quercus project. So now you might ask, why would you do this? And I tell you why, because Quercus has a very nice continuous testing approach. So if I set up a specific profile, I say, for example, test profile. So again, this is not production. This is just a system test. ST stands for system test project. If I say Quercus development mode, then I can build up this development mode, and what you do, it listens to your key input, and this is really, really fast. I think this is the fastest way to run your tests. If you run R, then it will run very quickly all of your tests. So you see one test takes a little bit longer. I will show you in a second that you can do this also real quick. And I have also a Selenite test here for a UI test, which we can talk a little bit as well if you have questions. And now you saw, okay, it took 11 seconds, but mostly because the tests actually take time. So the tests do something. It's not that the tests themselves are slow, but they run in a certain time. But to show you that it runs really quickly, I will just include one specific test. Let's say a Quercus test include pattern. I can say, for example, this one create order naive test, the one that you've seen, I can include this here, and then it only runs this one, for example, and I can say, run this test, and you see how quickly it runs. You hear it, my key press. Now it just runs the test, it does the HTTP connection, and then it returns. And I can prove that it runs in this way. So I have, what is this? Something like length, I think. Yes, 11, 12, 13, 14. So you see that it creates all of these orders really quickly because it runs your tests so fast. So this is what I think is the benefit of having just very simple test technologies. And again, I use just plain unit approaches with just some, test code quality, where I use the same mechanism that you would use in your production code. So I say, I have my test code here. It should be very readable. So that's why I need to delegate, if it makes sense, to a specific reusable component. And this component then, as I said, it is reusable. I can say I can have many, many different tests, and they all use the same system. And with this, it is manageable, even without some, test framework. So this, I think, is just not that required. And again, if you have a nice setup with such a mode that it can just run really quickly, and even your system test now, I was running in this development mode, so I just have to press one key and it very quickly, updates. I wish IntelliJ was so fast. So if you just press a key that it's not just, compiling, but already running the test, which is really fast. Because if I say, well, I changed something, again, let's do this again. So if I say, I have my code here again, and I don't know why my IDE is so slow. Hello world. You see, I very quickly have this one, and I see the output as well. So just, you always get a quick response from, well, any change you make. So I changed the test, I can rerun it, and I see if it works or not. Well, let's break the test. So you see actually that it's assert that it does not contain this one, and I rerun it, and then it says, I said, oh no, sorry, that was the wrong test that I changed. I should change the correct test, the one that I'm actually running. Does not contain. You see, it immediately gives you the response. While I was switching over it, it already reran the test, and you see, okay, what is the problem here? And you see, well, it does not expecting to contain, but found this, and so on and so forth. It said, okay, this, change it back, and you see already it's green again. So from a test feedback perspective, and this is, a system test. So I think this is just very fast and very helpful to do in such a way. Okay, Ivan, are there any more questions for this before we move on to the unit perspective? Hmm?
Rated. So I think he means oh, they tell me that there are some technical difficulties. Vladimir Sitnikov comments that it looks like Sebastian delivers why Java test frameworks are underappreciated rather than are overrated. I think he means your talk about Quercus framework.
Yes, well, exactly. So this is not a test framework, but it's about Quercus, what I was showing. Because for test technologies, I wasn't using anything else than just plain JUnit. So I said, okay, this one is different example down there, but I only use this Mockito SRJ, and it says I should update my version, and JUnit. So from a test perspective, I'm not, using test containers or so. I'm not using any Quercus test or something like that. So for me, I think this is just an approach that makes sense. I want to say one more thing for test containers, because I recorded some video of this. If you really like test containers, and I think it's a great technology, what you can do if you want to be faster, there's actually a way. I have some, I will show you at the end where to get this. I have some content where you say you can start up your code in a Java way if you want this. So it's very similar. As you see, I start 3 containers, I define a network, and then I said, okay, please, start everything. But the important thing is that you keep this running. Now it works with test containers that you run this in a separate process. So you run a separate JVM with this, and that works, and it works very well. But usually, you can do this approach. So this is nice if you want some Java API, but usually for me, it's just faster to say, I have some shell script that builds up everything, and I say Docker run 3 times, and for me it's just equally fast. But that just depends. But then you can have a similar approach. Okay, any other questions on this?
There is a question, how do you think, from Vasily Asachi, is it a good idea to try to write tests that can be run against production environment without changes? Or such tests should be separated from those used for development? And I would like to add my own question. We've been talking so far about end-to-end tests. So I believe this should be there are not be too many of such tests that you told us about.
Yeah, yes.
So maybe later we are going to talk about maybe lower level tests that are used in development and not in like this.
Good question. To answer the second question first, I think these end-to-end tests are actually more important for the overall microservice perspective than having only a lower level test level. Because the more we are in a microservice space or in a cloud native space where you have not much logic, but a lot of communication, communication to an external system, to a database, it's more about the integration than it is about specific, algorithms or so. So algorithms are important, and you have to, have some proper test technology to appreciate and test them. But I think that system tests are really important for your project to actually know that it will work for your user, because it uses the same approach, like in production. And for your first question, for the production test, it depends. So this test, for example, it would not quite work. Why? Because it assumes that the barista system is a mock that you can change. But for example, you can use this test against production. Would I do this? I don't know. It depends on the project. If it helps you to have something like a dummy order, this is a very good idea because it tests that your API is working. But I would create either a separate project or a separate suite of tests that might use the same functionality, but that don't get either triggered or separately, or that you can define separately that it only contains these tests that you actually want to run in production. So it depends on your project. If you say you want to run the same set of test suite also in production, but from my experience, it doesn't always work, because then you have some, you have some assumptions that you are in a test suite setup, and this just would be different. So I would, do it in. That would be my answer. Hope this makes sense.
Thank you.
Mm-hmm. Okay, perfect. So now let's, I think, move on a little bit to a different test scope from a more, let me show this first on a unit test basis. So let's move a little bit down this testing pyramid. So we saw already these end-to-end system tests where we have the application running in a similar way like it would run in production. But it's also important to have something that I would call code level tests. So I don't necessarily call them unit tests, because it might be a unit or a more bigger unit. But the code level tests are, I think, interesting because, what you would do with tests like, I can show you some code here in my like coffee shop. When I say coffee shop create order, show you a little bit of code now. So this is my Quercus code where I say /orders. That's my HTTP response. And it will create an order here. So I can post some JSON and build this up and say coffee shop create order, which is this, this business use case here. And then it will just, persist something in my repository. So this is a very nice Quercus feature. It's very similar to Spring Data JPA and can persist things. And now you can say, do I want to test this class? And the answer, I would say it depends, because if I would like to write a test for this, like create order, it would be very boring because it only delegates something to a different delegate. So I would say it doesn't really make sense. I could say, I have something like, let's show you a naive test again. For example, where I take the coffee shop, I instantiate it, and then I use everything. So that's an extreme example. As you see, I use everything on a low level, that I say, well, please use some mocking and set this field. You might need to use some reflection, and then, check the status and test create order and verify that this was persisted and created. But, to be honest, I think this doesn't really make much sense, because, the test doesn't say much. So the good news is it runs really quickly if I run this test here, but it doesn't tell you much about, what you, that it really would work. And also the code is really ugly here. What you could do instead is to use, different test runner. So I wouldn't use this. This is just an example to run it with, Mockito, so you can inject something. But as you see, I would say it also doesn't, really make sense from this perspective. But what I do instead is what I call a use case test or component test. So what it does, it builds up multiple components that are involved in a specific use case, excluding the external systems. So for example, coffee shop, to say create a coffee order. So this involves the coffee shop, maybe all of these dependencies, maybe this order processor, and then I can verify if the communication was done correctly. And you can do this by, for example, having something like a Quercus test or a Spring test, so you can inject it and inject the mock and spy and all of it. But again, you will see that this just always takes a few seconds to start it up. So I pressed the key, and now it failed because I think of the database. Yeah, because it is already running. But you saw, doesn't matter, but you saw from the time how long it takes. So 1, 2, 3, 4, and now it's running, and now it failed. But it took 4 seconds to only build up. And of course, you can rerun this Quercus application. So if you have many tests, you don't need to wait 4 seconds every time. But it's just on average, it's too slow for me. You saw the different test. If I want to just run this, for example, and saying, okay, this just runs really quickly. And now my idea was to say, how can I actually use this without a framework to just have a fast feedback and still have manageable code? Something like this, where I can just make it more readable. And what I think, again, is the answer is to not use some nice test technology only, but to say, how can we include the code quality, or how can we improve it so that it's more manageable? So I call this use case tests here. And what it does, I have my coffee shop and my order processor in my production code. And on the test code, I have what is called a test double, or TD, that extends this class, and it can add its mocking logic. So you don't have to add all of this crazy logic in your test code, but you use it in the test double that are reusable components. So with this, I can say use case test and say, for example, new order, create order, and verify created order. And this coffee shop is a test double that extends this resides in the test code. This extends my class from the production code, so this works, why not? And I can set it up with the other test double. I can use this mocking logic here and verify and so on. So this works really nicely. And then I can say verify create order, and it will include the methods there. So I don't have this lower level logic in my test code. And as you see, the test code is much more readable, and I can create this much better and change it and everything. And still, the good news is this runs really fast because it's only JUnit and Java. And plain JUnit and Java runs really, really quickly. So you can run hundreds of tests in no time. And I think this makes more sense than to just include some test framework that always requires you to wait for a few seconds, which I think is not fast enough. So again, I think the answer for that is more to care about your test code quality than to use a test framework that might slow you down. but it depends on which framework. So again, I say this, test frameworks, don't use them. Of course, JUnit is also a test framework. But for me, I'm talking about test technologies, especially the ones that deal with your life cycle. So that want to, control your test life cycle, which I think is just not fast enough, because you're more flexible and, you're more flexible in your code to create your own whatever you want. If you use just a plain test runner like JUnit, and then, do the whole thing in your Java code and think of some structures that might make sense for a bigger project. Especially if it's a real world project that is more complex, you will see that over time, you really need, many of these reusable components that you can use in many, many tests, and logic that you write here, you can reuse in many cases. So it's just much more, it makes much more sense from this regard. So that's just, my experience that makes more sense here. So it's a similar approach where you use reusable components to make this more worthwhile. So Ivan, do you have some thoughts about this, or do you have some questions about such an approach?
Yeah. Some thoughts. I already always try to avoid creating Spring context during testing, so it's really slow. So it's better to I don't know, create your own factory if you can avoid injection. But it's a new idea. The new idea for me was creating these TD classes, test double classes. Mm-hmm. So it's really something new, very interesting.
Yes, then the nice thing, is I think it just helps you to change some of the mocks that are directly part of this class, right? So you could also use some dependency that is a different class, but I think it makes more sense to just subclass it and then change things, like a proxy would in your enterprise framework, and then, change it there and then say you use Java for it or Mockito. It's really fast. You do the effort once, so it's still a little bit of effort, but it pays off because it's like an investment. You make it once, and then you create this class, and then you can reuse it, and change some things only in one way. So this is more manageable.
Because very cool. From my experience, there are some times that you need to create application context, like if there is some magic that tied to static methods or static fields in I'm talking about Spring Boot. So you just cannot avoid creating application context. But in most cases, you can avoid doing this.
Yes, no, that's correct. Sometimes you need it, or I also have sometimes like one of these tests where it's in the whole test suite, so it's okay. But that if you really need it, but if you can avoid it, it's good. Yeah, that's true. Well, and another thing that is also important that we know. So with all of these tests, if you're what do you do when you refactor your code, right? Like what if this structure changes? Then typically, if you have a very easy or too naive test structure, this becomes a really big problem to just change all of that code, and that's really really annoying and takes too much time. So you throw away all of your code. But if you have such a test double class, you have one place where you'd have to make the changes or where you have to make the updates, and then you only use this interface of these methods in your test code. So it's kind of like, actually nothing new, same idea of just using some reusable components in your test code, not only in production code. It's allowed to have test code quality in your test code as well. This is, I think, another important part. Okay, so let's talk a little bit about some key takeaways, because it's really, something that, first of all, the test code quality matters. I think this is really important, and I think it matters more than some, test technology. And in any way, it helps. You saw this in system tests and also in lower level, whether unit tests or use case tests, to create reusable test components in your code. So that might be a class, that might be a subclass or something that then you use from different tests. Often that is not compatible with some test framework technologies. It depends. So I think this is always a good idea, because then your code is more maintainable, because you outsource the need for a change into a specific component or class, and then you can do it from there. And what is also really important, what you saw, especially with end-to-end tests, this is really helpful because, believe me, when you're in the code flow, you don't want to wait. You just press a button and it's there, the result. It's really nice. And that's where I say testing is really fun, because if you change something in a production code and you press a button and you get the response immediately, it's really nice. And, you want to write more tests because they make your project better, to have fast feedback and short turnaround cycles, which you have seen, especially with an approach like Quercus Dev. In Spring, there's a similar thing with Spring Dev Toolkit. I can say the Quercus approach works really nice out of the box, but whatever technology you use. And you can also be, pragmatic with that, or experiment a little bit with this just locally for your test setup. So I think it really makes sense to invest some time to make your setup faster for short turnaround. If you have, for example, some, development mode that connects to a Docker container that can, connect to it quickly, reload. If it saves yourself some time, this is a good investment, because over time you run these many, many times, and the more you run it, the better the quality. So this is just a good thing. In order to get there, my observation is that you need to separate the life cycles from the test and the test environment, because the more you tangle them two together, well, from my experience, the more problems you have, because things are slower and it's more difficult to separate them if you want to reuse a test, for example, to reuse it to a production or to a staging environment or to a test environment that doesn't run locally. And on average, it also runs, it doesn't give you a quick turnaround. Even if it has some optimization, it just takes longer. And also, as a good tip, try to use some reusable test scenarios. So ideally, they're idempotent, that you can run them a few times, but this depends on your business, on your use case, if you can do this. But it just helps you, because then it's quicker for developing. If you don't need to quickly every time restart something or recreate, so you can just run. This just helps. And I think as the most important takeaway is that the test code quality is more important than the choice of technology, like which test frameworks you use. It's more important to care about the quality, especially abstraction layers and using delegation that make your code more maintainable than using some fancy test frameworks, especially if the test frameworks then tend to make your overall build slower. So this is also, I think, a very important part. So do you have some comments on this, Ivan?
Sebastian, thank you very much for your nice talk. I think we don't have much time left, and it's better to discuss the questions in Zoom chat. I cannot just but agree with you about the fact that fast turnaround is very important, and programmers they like to write more tests than they can just press this green triangle in IntelliJ IDE and get the result instantly.
Nice. That's very
important. Very true.
Perfect. Yes, so I hope this was interesting, and also now I want to finish it off. Well, if I may, with a few words in Russian, если можно.
Конечно, давай.
Давай, да, потому что вы знаете, что я учу русский, чуть-чуть. В общем, сначала большое спасибо, что вы слушали. Но особенно потому, что я хотел бы сейчас быть в России, и, например, в Джакру офис. И, для меня, не знаю, я долго думал об этом, но, в общем, все равно я счастлив, что могу сделать эту презентацию такой, и я надеюсь, это было интересно. Но я хотел, потому что я думаю, я верю, что открытое общение и обмен знаниями являются наиболее важными для того, чтобы делать мир немного лучше, а также для того, чтобы не усиливать изоляцию и не позволят распространять ненависть и дезинформацию. Я из Германии, и мы знаем, что может случиться, когда пропаганда и ненависть по отношению к другим людям становятся слишком сильными. И я надеюсь, что люди смогут сохранить свои связи с другими странами и видеть, что происходит в мире. И я надеюсь, что скоро снова могу поехать в Россию, что все изменится к лучшему, и что люди смогут быть открытыми и относиться к другим с любовью. Спасибо.
Спасибо, дорогой. Мы очень-очень благодарны тебе за выступление и за эти слова. Они сейчас очень важно нам всем от тебя это услышать. Большое спасибо тебе от меня лично и от Джуга, и от наших слушателей.